Hello, in this video I'll be showing you how to answer the NSAA 2016 Section 1 Question 43. A chromatogram was produced for 4 separate dyes, W, X, Y and Z, using filter paper and a water solvent. A second chromatogram was produced using a mixture of 2 of the dyes, again using filter paper and a water solvent. Here are the 2 chromatograms. Which of the following statements, if any, are correct? Statement 1. The concentration of dye W is twice that of dye Z. Statement 2. The mobile phase is the filter paper. Statement 3. The mixture in the second chromatogram contains dyes Y and W. So let's look at each statement in turn. So statement 1. The concentration of dye W is twice that of dye Z. Well, the distance travelled by the dye is independent of the concentration. The distance travelled depends on how well it actually mixes with the solvent. So if it mixes well with the solvent, it will travel high up, and if it hardly mixes, then it won't travel that far. It's independent of the concentration. So statement 1 is incorrect. Statement 2, the mobile phase is the filter paper. Well, let's remind ourselves what the mobile phase is. So the mobile phase flows through the stationary phase and carries the component of the mixture with it. So our question said, using a filter paper and a water solvent. So it's quite clear that the water is the solvent that carries the dyes. So the water is the mobile phase, which implies that the filter is the stationary phase, which makes sense because the filter paper doesn't actually move, it's stationary, and it's the water that's moving up the filter paper. So therefore, statement 2 is also incorrect. Statement 3, the mixture in the second chromatogram contains dyes Y and W. So some students will immediately look at the both chromatograms and see that, oh, there's 3.2 here, there's 3.2 there, there's 4.1 here, and there's 4.1 there. So it's X and Z, not Y and W. So the statement is incorrect. But no, we're going to work this out properly by using RF values. So the RF is the distance travelled by the dye over the distance of the solvent front. So looking at dye W, we have a distance of 8.2 divided by the solvent front distance, which is 10. This gives you an RF of 0.82. Doing the same for Y, the distance travelled is 6.4 divided by the solvent front, which is 10, and this gives you 0.64. Now looking at the second chromatogram, so we have the RF values in the mix are 4.1 divided by 5 and 3.2 divided by 5, which also gives you 0.82 and 0.64, which implies that it is Y and W that's in the mix and not X and Z, which some students would have jumped to straight away. So in fact, the statement is correct. So looking at our list of options, we know that only statement 3 is correct, so the correct answer is D.